Have you ever just looked up at the sky and wondered, how in the world did those things get made? You know, those giant, fluffy clouds? Well, today we're going to open up the Cosmic Cookbook and break down the secret recipe for making a cloud. But first, let's start with a question that just messes with your mind a little bit. How can a cloud, which can weigh over 1,000,000 pounds, we're talking jumbo jet territory, just hang out up there, floating? It seems like it should be impossible, right? Well, the answer is one of the coolest parts of our recipe, and we're about to figure it out. Okay, so before any chef starts cooking, you have to understand your ingredients. So let's just get down to basics for a second. What is a cloud, really? See, a cloud isn't just some vague puff of vapor. It's a collection of actual physical things, tiny little water droplets or even tinier ice crystals, all just hanging out in the atmosphere. And remembering that they're made of real stuff is the key to this whole recipe. All right, let's get to it. Just like any great recipe, making a cloud takes a few key ingredients and a very specific method. So let's break down exactly what we need. So, our first two ingredients are water vapor, which is just the invisible, gassy form of water that's all around us, and air that's getting colder. You gotta have both. You need air that's packed with moisture, and you need a way to cool it down. That's what triggers condensation, the magic moment when that gas turns back into liquid. And the method for cooling that air? It's just brilliant. It's called adiabatic cooling. Basically, as a blob of air rises, the pressure around it gets lower. This lets the air parcel expand and, well, think about letting air out of a tire. It feels cold, right? Same idea. Expansion causes cooling. And once that air cools down to a special temperature called its dew point, boom, condensation starts to happen. But wait a minute. Our recipe is still missing something. There's a secret third ingredient that is absolutely 100% essential. Without this, none of it works. You get no clouds. These are the real unsung heroes of the sky. And that secret ingredient is basically dust. Well, to be more scientific, it's tiny particles that we call cloud condensation nuclei, or CCNs for short. See, water vapor is picky. It can't just condense out of thin air. It needs a solid surface to grab onto, to cling to. And these microscopic particles are the perfect little platforms. Now, not all these little particles are created equal. Some of them are hygroscopic, which is a fancy way of saying they're water-seeking. They actively attract water molecules. Others are hydrophobic. They repel water. And while clouds can form on the water-repelling kind, it's the hygroscopic ones that are the true superstars here. You can think of them as tiny moisture magnets. And you already know exactly how this works. Think about leaving a box of crackers open on a humid day. What happens? They got all stale and soggy, right? That's because they're hygroscopic. They're literally pulling moisture right out of the air. The best cloud seeds do that exact same thing, just on a microscopic level. So, where did his magical little particles even come from? Everywhere. I mean, we're talking about microscopic dust, smoke from fires, salt crystals from ocean spray, ash from volcanoes, pollen from plants, even the stuff coming out of our cars and furnaces. The air is absolutely full of these tiny cloud seeds just waiting for the right moment. Okay, so our ingredients have combined, condensation has happened, and ta-da! We officially have a cloud. But this, my friends, is where things get really, really interesting. Because making a cloud also creates a brand new puzzle, one that baffled scientists for a long time. What we've made is a cloud that's built from billions and billions of these microscopic droplets. They're so incredibly tiny and lightweight that even the gentlest air currents can keep them floating up there. And that is the answer to our first big question. A 1,000,000-pound cloud can float because its weight is spread out among countless droplets that are just too small and light to fall. Now, just take a second and look at this number. 1,000,000. It's a huge number, right? And it is the absolute key to the next and maybe the most mind-bending part of this whole process. Because it takes about 1,000,000 of those tiny little cloud droplets all bumping into each other and merging together just to make a single average-sized raindrop. The difference in scale there is just, it's almost impossible to wrap your head around. And that leads to a really crucial question, doesn't it? If the droplets are that small, and if condensation is a super slow process, how on earth do we ever get rain? How do a million of these things manage to find each other to become a single raindrop? It's a huge puzzle in meteorology, and it just shows you how complex the journey from cloud to a rainstorm really is. So for now, let's wrap up by looking at what our recipe can actually create. Because just like one dough recipe can make you a pizza, a loaf of bread, or dinner rolls, our cloud recipe can produce some stunningly different results in the sky. So let's check out a few of the absolute masterpieces this recipe can bake. Each one of them is like a visual clue, telling a unique story about exactly what's going on way up there in the atmosphere. First up, we've got lenticular clouds. These incredibly smooth, lens-shaped clouds are famous for looking a lot like UFOs. You usually see them on the downwind side of a big mountain, where the air is flowing over it in these amazing wave patterns. Then you get these things, mammatus clouds. Aren't they incredible? Those really distinctive pouch-like bulges hanging from the bottom of a cloud are an absolutely spectacular sight. But you should know, they're usually a sign that some pretty stormy, unstable weather is on its way. And here we have cirrus uncinus, though they're sometimes called mare's tails. You can see why. Their delicate, hook shape is beautiful, but it often means that a change for the worse in weather is coming. They're kind of like nature's own early warning system. And finally, we have the term fractus. Now, this isn't really a type of cloud on its own, it's more of a description. When you see normal stratus or cumulus clouds that look all broken up, torn, and fractured, that's fractus. It's a sign that the cloud is starting to break apart and dissipate. So, the next time you look up, just remember the recipe. Remember that every single cloud you see is telling this incredible, dynamic story of rising air, of invisible particles, and of the journey of a million tiny droplets. So the only question left is, what story is the sky telling you right now?